So the type of program we're doing is called online programming, right? And what does that mean? Doing it at the robot. Okay. Is everybody okay there? Also, there was a safety video y'all was really supposed to watch. And, that's part of the information on that. It will definitely be on test the rest of the term, so you'll need to go do that. Plus anything that's on that document y'all were supposed to be reading that I wrote, right? You'll need to be really working on that. Everybody okay on the modes of operation? I think we've already went through these slides, but I need to go back and touch on that. So we at least have 2 modes of operation. Some of the robots have more, but we have what we call teach mode, and then we have what we'll refer to as play mode. Are y'all okay there? So what's the difference between teach mode and play mode?
Teach mode is program edit.
So this is where we actually do the program, right? We have to have a teach mode. We can run the program in teach mode, but it requires the 3-position enablement switch to be in the center position, right? It has 3 positions. You can single step the program, you can run the program, which in this class we'll refer to as teach, run, and teach single step. We use single step to verify points. We use run to verify the program. That makes a difference. So if we single step a program, it's not going to give us the path the robot will follow. It will go to the points. Is everybody okay? Also gives us the ability to edit the program, save, copy, delete, and rename programs. And what's editing? It's just changing the program, right? So if we need to touch up a point, that's going to be editing. If we need to change the speed, that's going to be editing. If we need to change the round off, that's going to be editing. In play mode, we can select a program. We can abort a program, right? We can run programs. The 3-position enablement switch is no longer required. All your safeguards have to be in place. Y'all understand that? So that means you're going to have to lock up the work cell to run this. You can do single step, or we can do, we'll call it play single step and play run. We have the 2 options to do that. Everybody understand that? So a program is a group of instructions arranged in such a manner that it will cause the computer to perform a task. Creating a program in Roblox, we call that what? Teaching, right? Syntax is what syntax? Written language. It's the written language. So syntax is the correct way of writing in a language. In computers, your syntax has to be perfect. So remember that. Normally when we insert a move instruction, it's going to give us the right syntax, and you'll have to go in and modify it to provide the additional information. Online programming, teaching the program with teach pendant. The parts of an instruction, we have a line number, then we have a command, and then we have the information required by the command, right? If required. So a lot of times the information required by the command is an optional feature. But it's going to be in every move instruction that you're doing right now. Every move instruction requires information. What's one thing it requires? Well, that's the command itself. So when I say what's required by the move instruction, I've already told you the command. So we're down in here. What's required by a move instruction? The speed. Definitely the speed, right? And what else? We refer to it as round off. But it's, what is round off? Yeah, midpoints is how accurately it will go through midpoints. I understand. We'll refer to it as fine and continuous, even though these robots call it a different thing. If you specify a fine move, then it will stop at the midpoints. If you specify a round off or a continuous motion, it will go through the midpoints by a degree that you specify. Y'all understand? And of course, that gives us the ability to cut corners. Everybody okay? Everybody okay on names? So every program has a name. When you create a program, one of the first things it's going to ask you to do is do what? Give it a name. And then we use those to select programs to run. We use that to select programs to edit. We use that to select programs to copy. We use that to select programs to delete. So you need to come up with a name. Now in this class, we're going to use 8 character names. And why are we doing that? Because some of the robots don't require, they allow you to use longer than 8. Some of them don't. But to give uniformity in the way I grade labs, we're going to limit our file names to 8 names. Some robots have to specify a folder. This is especially true on the ABB. The ABB, if you don't specify a folder, it keeps putting programs in the same folder. Does that make sense? And you'll end up with a bunch of garbage going down the wrong path. So, normally we can take the default folder, but you have to be careful in the ABB, so watch out for that. And of course, consult the appropriate manual. So teaching points, move the robot to a position required by the program. Programs must be taught in order to perform a task, right? So that's what y'all fixing to do. You're fixing to teach points. Teaching points is probably one of the easiest things you do on the robot as far as just selecting how you teach a point. You're going to be able to select at least 3 different move instructions. What are 3 move instructions? Joint, linear, circular. Don't get joint move and joint jog confused with each other. And y'all having problems with that. Every morning quiz that I've given so far, every one that I've given so far, these things have been missed. And this is probably one important things that you learn about programming robots is how you can jog it and what type of moves are available. So how can we jog this thing? In 4 coordinate systems. We have 4 available to us. What are the 4? Joint, world, tool, and user. Good. And then we have at least 3 types of moves. What are the 3 types of moves? Joint, linear, circular. One of them is what we call a control path move. 2 of them are control path moves. What are those? Control, no. We're talking about moves. We're not talking about roll, pitch, jog. That comes into place with jogging. We're talking about, we have 3 moves. We have 3 type of move instructions at least. Some of them support more, but every one of them support these. Okay. One of them is called an uncontrolled path move. 2 of them are called control path moves. Linear and circular are control path moves. Joint moves are what we call uncontrolled path moves. So when you do a linear move, it's going to move in a straight line. When you move a joint move, it'll never move in a straight line. It'll take a path to try to get from point A to point B as fast as it possibly can. And a straight line is not necessarily the fastest path. We explained that, right? Why? A straight line is the shortest distance between 2 points, but it's not necessarily the fastest path. So you got on Highway 11 out here, it goes all the way to Birmingham, all the lights are green, and the speed limit is 100 miles an hour. You fly an airplane in a straight, you fly a drone in a straight path, and you can do 30 miles an hour. Who's going to get there first? Going up Highway 11, right? Because that's a pretty much, but it's not a straight path. It has curves and all kinds of stuff. So why a joint move is faster is that it's the ability to turn those motors on fastest. The controller don't have to do any calculations. It just turns all the motors on at a percent speed. When it's doing a joint move and a circular move, the controller has got to do a lot of math, right? You understand, to understand what axis to move to cause that end of arm tool to move in a straight line. It's going to take quite a bit of computer power. So our control path, our uncontrolled path moves, we're going to specify a percentage of speed. It's actually a percentage of a percentage. So I think y'all probably notice you have the ability to set a speed, and then you on the teach pendant, and then you specify a percentage of that speed. So your instruction specifies a percentage of a percentage. That makes sense. The Motorman is probably the one that's most limited because all you got is fine, slow, medium, and fast. But if you get on the FANUC, you see you hit that teach pendant, you can go 5%, 10%, you can go 1% of, and then your joint move would move at 1% of that speed, right? Does that make sense? Accuracy is what we call round off, and then defaults. So y'all, what's a default? That's right. So when you insert a move instruction, it's going to automatically give you a certain speed, and it's going to automatically give you a certain accuracy. Many type programs require other instructions besides move. We're just going to try to do the move instructions, but if I want to open a gripper, we don't open the gripper with a move instruction, right? You understand? If I want to make the program loop, keep going over and over, we don't do that with a move instruction. So as we move through the class, we'll look at those higher level instructions. Those are also covered inside that textbook. Types of moves, joint moves, we've already talked about, linear moves, and then circular moves. So are y'all okay with these three? I think the ABB supports a spline move. Some robots will report what we call weaves, which we use in welding. So normally when you do a weld, if you got two metals that have a gap in between them, then the way you actually solder them is weld them is you do what we call a weave. Some of the robots support a weave, but we don't have welding here. We got, but that would be some of the other instructions you would move. You would have to. Now, a weave instruction, you have to specify the frequency, so that's how fast it moves back and forth, and then you have to specify the amplitude. So there's several other things, so that would be in part of the information section. Some of the robots support what we call a spline move, which would be a move like that, where a circular move is going to be a move like that, right? So those would be additional moves that would be available to you. But once you learn the three basic moves, then all these other moves make more sense, right? And of course, you'd have to pick up those in the robot. The only ones I put in here for some reason was the Motorman and the FANUC. So this would be an example of a circular move. A joint move for the FANUC. So we start off with J. What does J mean? It tells the FANUC I'm doing a what? It tells I'm doing a joint move. What's a P1? What do you think that would be? That would be the point number, right? What's this right here? Speed. And what's this right here? This is what we'll refer to as the round off. So that means this guy's going to cut the corner. So on this one, the smaller you make the round off, the more accurately it's going to hit the corner. So on the FANUC, you got two options. You can select fine or continuous. If you select fine, you don't have to enter anything because a fine move it's going to do what? It's going to hit the point. If you specify continuous, then you're going to have to specify a percentage of that. This is a circular move. Circular move requires three points. So this is line number 1. This would be 0.5. We're going to move 100% fine. Does that make sense? And then when you say circular, you're going to have to teach 2 more points, because an arc requires 3 things. It requires a start, and it requires an end, and then it's got to have an intermediate. This is the motor man. So what type of move would this be? Linear. Well, the velocity would be 50 millimeters per second. And position level 0 would be a fine round off. So if I use a position level 0, it's going to do what? Now the ADB, the KUKA, I need to put this up here. They call their round off a zone. So when you set the zone, if you put a zone 0, it's going to hit the point. And the bigger the number, the more it's going to round off. But every one of them basically follows the same syntax, which means we have a line number over here that might not be visible. We have a command, and then all this is information that's needed by that command, right? By the way, on the motor man, if you don't specify it by default, it's not going to give you a position level. What it'll do is it'll automatically round off depending on the speed of the move. So that's not good. So what you need to do is figure out, if you're on the motor man, how to add the position level out there. Okay? We've already talked about this. Everybody okay? So when we use single step, we're not verifying the path of the program. We're using that to verify points. Does that make sense? If you do run, and this is some of the things that y'all missed on the test. We went over the test, by the way. So y'all, in the tests, I think I've made it available in the previous test section. I need to go back and check that. And there was quite a few questions that's going to move from test 1 up to test 2. So y'all need to go back and study that test before test 2. I think test 2 is next week. Probably, because we're in every 4 classes about to give 3 tests in 8 weeks. You know. Single step. Some of your robots skip over non-move instructions. You got to be careful with those, because you're single stepping through a program that you have you're supposed to open the gripper up and come down, and it skips over the open gripper. Then what could it do? It could collide on the next step. So pay attention to that. Some of them you can select, so whether it skips over non and move instructions or if it adds them. So right now it's not going to be anything to us, because all we're trying to do is teach our first program, right? But one thing we got to do is to single step into teach mode, we got to have the teach mode selected, right? Number 1. We got to have the 3-position enabling switch in the center position. Everybody understand that? And then every time we're going to press a key or a sequence of keys, and it's going to do what? It's going to do 1 step, and then it's going to stop. And then what would you have to do? You're about to release one of those keys, look it up in your manual, and then press it again. And when you press it again, what's it going to do? It's going to do 1 program step. And then it's going to do what? It's going to stop. So you'll constantly have to let that thing off. During steps, so you can let go of the teach pendant. If you need to verify the height of a point, you can get your ruler out. You can check the height of the point. Or you can come back and pick up the teach pendant, hit it again, and press it, and it will step to the next point. You can step backwards. Every one of these gives you the ability to step backwards or forward. So if you step to this point, and you make a little change on that, and you want to check the previous point, just tell it to do what? Go backwards. So you can step forward or backwards in single step mode. But you can't do that in play step mode, but you can in single step mode. Step forward, step backwards. You can edit a line, you know, so you can change the contents, you can change the speed, you can change the point, or you could change the round off. You can step it forward, step it back, and see if it works the way you want Use primary to verify a program's taught points. The robot will not follow the path when the program is run. So what happens, it's not going to follow the path, but it's going to verify the points. Odds are if you're doing a circular move, it'll follow the path, but if you do a joint move, it's going to be completely different when you run the program. Teach run, the robot will execute the program from start to finish. Teach pendant controls will have to be activated, pressed, or moved and held in place during the program execution. But I think you can run the program backwards if you're in the end, so y'all might need to look at that. Some of our robots support a high-speed teach. So high-speed teach doesn't come into play when you're jogging the robot. High-speed teach comes in play when you put it in teach run. So when y'all saw me run the big FANUC over there, that was full speed. That was high-speed teach. So we got to be pretty careful. The KUKA robot, and what they do on a low-speed teach is they limit the speed of the robot to 250 millimeters per second. So what that means is if you put a 1,000 millimeter per second move and you run it in slow speed teach, it's not going to move over what? 250 millimeters per second. Now the KUKA, everything's decreased 5%, but none of y'all are on the KUKA here. So, I mean, if you run slow speed teach on the KUKA, it is really slow. High speed teach is supported by the ABB. It's supported by the KUKA and the ABB. The FANUC and the Motoman, you don't have a high-speed teach. So when you run your program in teach mode, it will be limited to 250 millimeters per second. Automatic safe go. Work cell safeguards must be in place before the controller allows the robot to move. You do not press the 3-position enabling switch when you switch it to automatic mode. Right, you'll understand that. But you got to switch it to automatic mode. How are you going to switch it to automatic mode? There's going to be a switch somewhere. So you can't switch it from automatic, from teach to play by hitting a button. You got a selector switch. The selector switch is either going to be on the teach pendant or it's going to be on the controller. It's on the controller for the FANUC, and it's on the controller for the ABB. It's on the teach pendant for the Motoman. So whichever one you're on, that's the way you switch between what? Between teach and play. Play single step. Buttons are on the teach pendant or a controller must be pressed to cause the program to step to the next instruction. But you don't do this with the deadman switch. So if your play button is on the teach pendant, all you have to do is keep pressing that. If your play button's on the controller, all you have to do is keep placing that. The only one where this is on the controller is on the FANUC. So it's that big nice green button on the front. So what you'd have to do if you have it on single step is you'd have to press the green button, let it do one step, and then the green light would go off, and then you'd have to do what? You'd have to press it again. That's a pain in the butt on the FANUC over on the manufacturing line, because you got to come to the front of the robot to tell it to run, then you have to go back to the controller to single step. So robot move. So play run. The robot moves at the speed specified in the instructions. Times the percentage set on the teach pendant. The 250 millimeter per second speed limit is no longer applies. The controller will run the program from start to finish. And later on, when we learn how to make it loop, it's not going to finish, right? You understand? We'll tell it how to loop unless we put some type of condition in there, which you won't be doing in this class. But if you take the robot projects class, we'll get into some really advanced instructions, like trying to make it loop 5 times or 6 times or something like that. So the round off for the Fanuc is called continuous and fine. The round off for the Motorman is called a position level. KUKA, they refer to it as continuous, but it's available on what we call CDC data. I need to check that too, but none of y'all is doing that. The ABB calls it a what? A zone. The programmer can specify how accurately the robot hits points that change the robot's direction. And we use round off to allow it to follow lines that we cannot follow with basic 3 instructions, right? And that's it, guys. So we went back over this. Of course, you need to know what it's called on your robot. There'll probably be on a question on the next test where you're going to have to tell me what it's referred to on the robot that you're assigned to. So what we're going to do is y'all need to get through with y'all's first program today. It needs to be through. And like I said, we try to open up the lab on Fridays, but I won't be available the next 2 Fridays. We're having a car cam thing. Not this next 2 Fridays. I won't be available. Won't be. Yeah. Tomorrow we're having a car cam meeting here. That's a big. Y'all probably see car cam a lot around here. That's a consortium that we're a member of that gives us a lot of money every year. And then next Friday, I have a doctor's appointment, but we'll be working. We're trying to get some software installed on our laptops over there so we can start that mechatronics program. So y'all got any questions? So let's check and see. Make sure we know what the next test is. Yeah, so the next test is it's next Thursday. All right, guys, until after.